Hello and welcome to Cognito Key. Just take a look around you for a second. Your phone, your laptop, even your TV. You've noticed they're all getting smaller and way more powerful, right? Well, today, we're going to pull back the curtain on a secret piece of engineering that makes it all happen, the resonant converter.
But first, a quick question. Have you ever been working on your laptop and felt it get really warm on your lap? Or noticed your phone charger is hot to the touch? You know that feeling? As our devices get faster and smaller, they've got this one huge challenge. They waste a ton of energy as heat. Let's dig into why.
So, what's the main culprit causing all that wasted heat? Well, it all comes down to something called the high-frequency switching problem.
See, inside every single power supply, there are these tiny little switches, and they are flipping on and off millions of times every second. Now, the faster they switch, the more electrical stress they create. You can almost think of it as electrical whiplash. These super fast changes in current and voltage put a massive strain on all the components. And all that constant high-speed stress, it has to go somewhere, right? It shows up as two really big problems. The first one is switching losses, which is just a technical way of saying wasted energy that literally escapes as heat. The second is electromagnetic interference, or EMI, which is basically electrical noise that can mess with other parts nearby. And this chart here illustrates the dilemma perfectly. You see, as we crank up the switching frequency to make our electronics smaller and faster, the switching losses don't just go up a little, they shoot up like dramatically. It's a classic engineering headache. Which brings us to the most important question of all. How can we get all the good stuff from high-frequency switching, smaller, faster gadgets, without all the bad stuff, like wasted heat and all that electrical noise? Well, the answer is surprisingly elegant, and it's found in a concept you might even remember from physics class, the beautiful art of resonance. I absolutely love this slides analogy. Just imagine you're pushing a child on a swing. If you just push at random times, you're going to struggle, right? It's clumsy, you waste energy. But if you push at that perfect moment, just as the swing hits its peak and is about to come back down, you can send it flying with almost no effort at all. That perfect timing, that's resonance. And that is exactly what a resonant converter does. It uses a carefully tuned pair of components, an inductor and a capacitor, to create a natural electronic rhythm, kind of like that swing. This lets the switches turn on and off at the perfect moment of lowest stress. It's a technique we call zero voltage or zero current switching. So how are these smart switches actually put together? All right, let's pop the hood and take a quick look inside. At its heart, a resonant converter is really just three simple parts. First, you have the switch network, which takes the incoming power and just chops it up into little pulses. Then, the resonant tank takes those pulses and shapes them. And finally, the rectifier network converts those newly shaped pulses back into the smooth, steady power your device actually needs. But the real magic, the absolute heart of the entire operation, happens in that middle section, the resonant tank. This is where those special inductors and capacitors create that natural swing-like rhythm, making sure the switches only turn on or off at that perfect moment of zero stress. Now, there are basically two main approaches to get that perfect push. You can either switch when the current is zero, or you can switch when the voltage is zero. But both methods have the exact same goal. By timing the switch to flip at the exact instant that the voltage wave or the current wave crosses that 0 point, you basically eliminate all that electrical stress we talked about earlier. No stress means no wasted energy and no interference. It's just an incredibly clever fix. Okay, so how do these two methods actually compare? This table lays it out for us really clearly. With zero current switching, or ZCS, we switch when the current hits zero. With zero voltage switching, or ZVS, we switch when the voltage is zero. But take a look at that peak stress row. Each method puts a totally different kind of strain on the switch itself. And this right here is the big trade-off. In a ZCS circuit, your switch has to be tough enough to handle a really high peak current. But in a ZVS circuit, the switch needs to be able to withstand a really high peak voltage. So which one is actually better for all our modern gadgets? And that brings us to the final and most important piece of the puzzle, the efficiency advantage, and which of these methods really comes out on top. Well, for most of the things we use today, there is a pretty clear winner. Engineers almost always prefer zero voltage switching, or ZVS.
And the reason why gets a little technical, but it's really important. Modern switches, like the MOSFETs you find in pretty much everything, have this natural, built-in thing called internal capacitance. ZVS actually works with this property. It uses it as part of the circuit. ZCS, on the other hand, kind of fights against it, and that can cause issues at really high frequencies. So, what is the big takeaway from all of this? Simply put, resonant converters, especially the ZVS designs, are the secret sauce to unlocking the potential of our modern electronics. They mean higher efficiency, so less wasted heat and longer battery life. They make smaller, lighter parts possible. And they cut down on that noisy interference, which just leads to more reliable devices for all of us.
This technology is already amazing, but it does leave us with one last thing to think about. We've come so far in cutting down on wasted power, but just imagine, what kind of future innovations could we unlock if we could one day get rid of that waste completely?
Thanks so much for watching this explainer on Cognito Key. If you found this useful, please do hit that like button, share it with someone you think might enjoy it, and definitely subscribe for more explainers that break down the tech that's shaping our world. What topic should we dive into next? Let us know down in the comments.